Hello and welcome to Vaslav's Maths tutorial. I'm going to do a question from M2, past exam papers in June 2012, edXcel. Question 6. Read the question carefully, and it's always useful to present all the information on a diagram to help us to understand the problem, hence make it easier for us to solve it. As you can see, we were told that there is a car. It's carrying a caravan and is going up a slope inclined to the horizontal with angle alpha, where sine alpha is equal to 1/14. I've started drawing this diagram. Obviously, the next thing is to put all the relevant forces. Okay, so I'm just going to do that. As you can see, I have put on the diagram all the forces acting on the vehicles. As you can see, there is a force of the engine which is pulling the car up, and there is we've been told that there is a resistance force on the car. So obviously that's opposing the direction of the motion, acting down. Similarly, there is a resistance force on a trolley as well, we've been told. Okay, the other forces are acting on the vehicles are the gravitational forces, which is along that direction, along the direction of the motion, is mg sine alpha, m of the trolley of course, and similarly mg sine alpha, which are both acting down as their gravitational force. So the resultant force I've written here, the force of the engine, take away the gravitational force of the car, minus the gravitational force of the trolley, minus the air resistance on the car, minus the air resistance on the trolley, should equal to ma, where m is the total masses of the car and the trolley. So the only problem is that we have not been given the force of the engine, but what we have been given is the power. We've been told that the engine power of the vehicle is 60 kilowatt, and we know that there is a relationship between the power and force. Power is force times velocity. So power is given to be 60 kilowatt, that's 60,000 watt, which is equal to the force of the engine, and the velocity, we've been told that at the time where the velocity is 10 meters per second, so 10. So from here we can work out the force of the engine, which is 60,000 divided by 10. It's going to give us 6,000 Newton. So let's go and substitute value in the equation. Okay, yeah, I've substituted the values here, the force of the engine and the mg sine alpha for the car, and this is the mg sine alpha for the trolley, and the air resistance is equal to ma, and the left hand side becomes 3680 is equal to 1600 So from here the acceleration at the time where the velocity is 10 meters per second can be worked out to be 2.3 meter per second per second. So that answers part A. Okay, part B then. Part B is asking us to work out the tension in the tow bar at this instant. This instant means where the acceleration is exactly the same as before, 2.3 meters per second. So if we separate the system and just concentrate on the trolley, we can see the tension force is acting upwards, and obviously as before the resistant force, the non-gravitational resistant force is acting down, and the gravitational force is also acting down. So let's write down the resultant of the force. You can say taking again this direction to be positive, so we can say the force of the tension, take away the mg sine alpha minus the resistant force of the trolley, it's equal to the mass of trolley. Notice this time's only mass of trolley, and the acceleration, which is as before. So if you substitute value and proceed, we should be able to work out T. Okay, then as you can see, I've done the resultant force here. The tensioner, the tension take away the gravitational force, and taking away the resistant force is equal to MA. And substituting value, as you can see, then solving for T, we work out T to be 1400 Newton. Okay, so that's the end of part B. Assuming that the trolley, after the rope breaking, travels distance of x before it comes to rest, we can say, using the conservation of the energy, that the total kinetic energy lost, some of it is down to the potential energy gain plus the energy loss due to the air resistance. So we know that the total kinetic energy half mv squared, potential energy is mgh, and the energy loss due to the distance, we knew that the force of the air was 200 times the distance x. That gives us the energy loss due to the resistance. Okay, and also we know that h in terms of x, h is equal to x sine alpha. So let's go and substitute value. Half m was 400, v squared 12 squared is equal to m, which was 400, g 9.8, h, we can replace h by x sine alpha minus 200x. Okay, as we can see now, we only got one unknown variable in here. So if you then operate that, we get 28,800 equal to, and the outcome of so this should be plus, the outcome of this is 280x. Remember, sine alpha 1 over 14, should put really 1 over 14 there, plus 200x. So what we get from here, x is equal to 28,800 divided by 480, and that would give us 60. So that means x is equal to 60 meters. So it takes 60 meters before the trolley comes to rest. Thank you.